What you're about to hear isn't just another technical update. It's a seismic shift in global military power. The West long believed that advanced jet engine technology would remain its exclusive domain, guarded by decades of expertise and industrial superiority. But now, all of that may be changing. Reports emerging from Chinese aerospace circles point to a mysterious new engine, one that's not only breaking performance records, but threatening to tilt the global balance of power. China has reportedly made a breakthrough in jet engine technology, achieving a 30% improvement in both fuel efficiency and thrust-to-weight ratios compared to its previous models. These aren't just marginal upgrades. This leap puts China in the elite club of nations capable of producing world-class, next-generation propulsion systems. It potentially ends decades of dependence on foreign engines and could reshape not just the battlefield, but the commercial skies as well. Over 8,000 commercial aircraft are expected to be delivered to China by 2040. A reliable, domestic engine could cut reliance on Western firms like GE Aerospace and Rolls-Royce, allowing China to dominate both military and civilian aviation markets worldwide. And let's not forget, whoever controls the sky controls the future. In this context, the implications go far beyond economics. They are geopolitical. This new engine is rumored to incorporate advanced materials like ceramic matrix composites, offer superior thermal management, and even feature next-gen thrust vectoring. If accurate, this is a game-changer. Jet engines are the crown jewel of aerospace engineering. They determine not only how fast a jet flies, but how far it goes, how much it can carry, and how effectively it can maneuver. For decades, China was stuck playing catch-up. No longer. Western military analysts are beginning to sound the alarm. A recent internal memo from the Pentagon, leaked to select defense outlets, allegedly states that China's propulsion capabilities are now years ahead of previous estimates. NATO officials are reportedly re-evaluating their airpower assumptions. The fear is simple, that China's next-generation fighters, powered by this new engine, could not only match the U.S. F-22 and F-35, but surpass them in some respects. For years, China depended on Russian engines like the AL-31F and even imported Ukrainian expertise to bridge its knowledge gaps. Reverse engineering was common, and domestic engines like the WS-10 suffered from quality issues and reliability concerns. But the new engine, likely a successor to the WS-15 or even a new designation entirely, signals the end of that dependency. It could deliver the one thing China's fifth-gen jets have lacked until now: world-class propulsion. The Chengdu J-20, China's stealth fighter, has often been compared to the U.S. F-22 Raptor. But despite its design strengths, it was held back by underperforming engines. With this breakthrough, the J-20 may now enter a new era of capability. Faster, more agile, more efficient, and critically, harder to detect. Some satellite images even show shorter takeoff runs and tighter turning radii at Chinese test facilities, suggesting increased thrust and advanced vectoring. Meanwhile, the FC-31, China's second stealth platform, could now be offered for export with a domestically produced high-performance engine. That alone would be a blow to Western aircraft makers like Lockheed Martin and Dassault, as more nations look for affordable, non-Western options with no strings attached. For countries under U.S. sanctions or those seeking strategic autonomy, a Chinese stealth fighter with a world-class engine could be very attractive. But this isn't just about jet fighters. The same engine architecture could be modified for a whole range of platforms. Hypersonic cruise missiles, unmanned aerial combat vehicles, or even scramjet-propelled sixth-generation fighters. Reports suggest that the engine's materials and cooling systems are capable of sustaining Mach 5+ speeds, opening the door to new global strike capabilities. Think about that for a moment. The U.S. has invested billions in hypersonic research, but China may now have the edge in propulsion, the most critical bottleneck in turning these concepts into real weapons. A missile or drone equipped with this engine could travel farther, faster, and with more flexibility than anything currently fielded by the West. There's also a civilian dimension to this race. Chinese state media have begun hinting at the inclusion of this engine, or a derivative, in upcoming commercial airliners being developed under the C919 and CR929 programs. That would directly challenge Boeing and Airbus, especially in markets aligned with the Belt and Road Initiative. A reliable, fuel-efficient Chinese jet engine could become a diplomatic tool, sold as part of aviation packages to developing nations seeking alternatives to the West. And unlike Western firms that rely on profit margins and shareholder returns, Chinese state-backed corporations are able to endure financial losses in pursuit of long-term strategic goals. This changes the entire playing field. While GE or Rolls-Royce must answer to quarterly reports, Chinese firms can afford to spend decades refining and deploying engine technologies under government subsidies and national industrial policies. Another major factor: workforce. China produces hundreds of thousands of engineering graduates annually, many of whom go straight into the defense sector. Talent programs like the Thousand Talents Plan have also brought in top researchers from abroad. Some Western intelligence agencies have even warned that dual-use aerospace technology from universities and think tanks may have been transferred to military applications under the radar. Compare that to the West, where aging populations, declining interest in STEM careers, and political disputes over immigration have led to significant shortages of technical workers. Developing a high-thrust, variable-cycle engine like this one requires not only money, but massive human capital. And China has it. Then there's regulation. Western aerospace firms operate under strict environmental laws and ethical sourcing rules. China, less constrained, can move faster. For example, additive manufacturing, a key part of this engine's construction, is still undergoing regulatory review in the US and Europe. China? It's already fielding it in critical components like turbine blades and cooling channels. These blades, reportedly made from single crystal superalloys, can withstand temperatures above 1,800 degrees Celsius, critical for sustained high-speed operation. Advanced 3D printed internal structures further enhance cooling and reduce engine weight. It's this combination of traditional metallurgy and cutting-edge design that gives the new Chinese engine its edge. The reported thrust-to-weight ratio is over 10-to-1, on par with the F-119 powering the F-22. But paired with China's stealth design philosophy and networked drone swarms, this engine may offer flexibility Western doctrines haven't yet accounted for. It's not just about power anymore. It's about how that power integrates into the whole system of future warfare. And that system increasingly includes AI. China is rapidly integrating machine learning into UAV operations, target acquisition, and even predictive maintenance for engines. An AI-controlled drone with thrust vectoring powered by this engine could outmaneuver manned fighters and overwhelm enemy defenses with speed and unpredictability. And then there's the H-20 bomber, China's answer to the US B-21 Raider. Still shrouded in mystery, this long-range stealth platform could finally be ready for deployment if powered by this new engine. With sufficient thrust and fuel efficiency, the H-20 could deliver conventional or nuclear payloads across the Pacific, bypassing current U.S. missile defense systems. The ripple effects are hard to overstate. Russia may lose its engine export market. NATO may have to reconsider its air defense posture in Asia. And developing countries, many aligned with China economically, could opt for Beijing's full-spectrum aerospace solutions, from satellites to stealth jets, powered entirely by homegrown engines. So here's the bottom line. If China has truly mastered this technology, it's not just a technical achievement. It's a political one, an industrial one, and a military one. It means the end of Western monopoly in propulsion. It means new alliances, new threats, and new frontiers in air power. The West is watching. Defense contractors are scrambling. Military strategists are rewriting assumptions. The question is no longer if China can build world-class engines. It's how many and how soon. And here's the chilling part. This may only be the beginning.